Good morning, dear students. Yesterday we discussed about type 1 problems. Today we discuss about type 2 problem. It is the same problem. Discuss the behavior of the sequence n plus 1 whole to the power of n divided by n to the power of n. So we already familiar with the formula. Limit n tends to infinity 1 plus 1 by n whole to the power of n is equal to e. So again we take this one as xn is equal to n plus 1 whole to the power of n divided by n to the power of n. So if we take your n as common factor, we get n to the power of n 1 plus 1 by n whole to the power of n divided by n to the power of n. So n to the power of n to the power of n cancel. So we get xn is equal to 1 divided by 1 plus xn is equal to 1 plus 1 by n whole to the power of n. Taking limits on both sides, we get limit n tends to infinity xn is equal to limit n tends to infinity 1 plus 1 by n whole to the power of n, which is equal to e, because it is a standard formula we proved already in previous. E is a finite limit, therefore it implies that the given sequence is convergent. So let's take another example. Second, 1 plus a by n whole to the power of n. We also take that as xn is equal to 1 plus, here is a by n. We already know that limit n tends to infinity is 1 plus 1 by n is whole to the power of n is equal to e. ಈ ರೆಸಿಪ್ರೋಕಲ್ ಏನಿದೆ ಪವರಲ್ಲೂ ಅದೇ ಇರೋದ್ರಿಂದ ಈ ರೆಸಿಪ್ರೋಕಲ್ ಏನಿದೆ ಈ ಇದ್ರದ್ದು ರೆಸಿಪ್ರೋಕಲ್ ಪವರಲ್ಲಿ ಇರಬೇಕು. ಹಾಗಾಗಿ ಇದನ್ನು ಎನ್ ಬೈ ಎ ಅಂತ ಬರ್ಕೊತೀನಿ. ಎನ್ ಬೈ ಎ ಆಲ್ರೆಡಿ ಅಲ್ಲಿರೋದ್ರಿಂದ ಸೊ ಟು ರೈಟ್ ಎ ಬೈ ಬಿ, ಬಿಕಾಸ್ ಎ ಶುಡ್ ಬಿ ಎ ಕ್ಯಾನ್ಸಲ್, ವಿ ಗೆಟ್ ಎನ್ ಬೈ ಬಿ. ಟೇಕಿಂಗ್ ಆನ್ both side limits, we get limit n tends to infinity xn is equal to e to the power of a by b. A and b are constant, therefore it implies that the sequence xn is convergent sequence. Here's a type. Let's take another example in terms of logarithmics. Last one in type 2, that is n into log of n plus 1 minus log n. So this is how we take xn is equal to n log of n plus 1 log m minus log n is log of n plus 1 by n, that is equal to n log n plus 1. If we take n as common factor, n into n plus 1 by n. So n cancel, we get xn is equal to log of, so this is 1, we are taking 1 by n. So log of n log of 1 plus 1 by n. Taking limits on both sides, we get limit n to infinity xn is equal to limit n tends to infinity log of 1 plus 1 by n whole to the power of n. So this is, we get limit n tends to xn is equal to log of 1 plus 1 by n is e to the base e, which is equal to 1. 1 is a finite quantity, therefore the given sequence is convergent. These are the type 2 problems. Next we can get type 3 problems, that is oscillatory sequence problems. These are the type 3 problems. So first one, discuss the behavior of the sequence 1 plus minus 1 whole to the power of n. So let's take xn is equal to 1 plus minus 1 not to the power of n. This is the sequence we have taken. This sequence xn is equal to this one. If you put n is equal to odd numbers, if n is equal to odd numbers, we get xn is equal to 1 plus minus 1 not to the power of 1 is minus 1, 0, 0, 0, 0. If n is equal to even numbers, we get xn is equal to 2, 2, 2. Therefore, the sequence should be look like xn is equal to 0, 2, 0, 2 like this. Therefore, we get here two values. Therefore, the given sequence oscillates between 0 and 2. This type of sequences are called oscillatory sequence. Let's take another example in this only. 1 plus cos n pi, same problem. I get previous problem only. Here the value of cos n is minus 1 not to the power of n. Same problem as we solved in previous. Therefore, sequence xn here also we get 0, 2, 0, 2 for odd and even numbers. Therefore, the given sequence oscillates between 0 and 1. Oscillates between 0 and 2. Last example 3. 1 plus sin n pi. 1 plus sin n pi. So we take xn is equal to 1 plus sin n pi. For any value of n, sin n pi becomes 0 as limit enters to infinity. Xn is equal to 1. Therefore, the given sequence is convergent. These are the problems about sequence. Thank you.